this is a solved example. It's stated here, شباب, 460 volt, 25 horsepower. So what is the 460 volt, شباب?
Line voltage.
Exactly, this is the line-to-line voltage. So if we would like to get V phase, because as you can see here, it's star connected, so we can say V phase equals 460 over
root 3.
Now, 25 horsepower, so this is considered as the output rated power. 60 hertz for poles, star connected wound rotor induction motor. Has the following impedances in ohms per phase, refer to the stator circuit. So all are referred to the stator side. We have R1, R2, X1, X2, and XM, but all are referred to stator side. So this is which is equivalent to R2 prime in our relations, and this is also equivalent to X2 prime in our relations. What is the maximum torque of this motor, and at what speed this slip does it occur? ها شباب, how to get the maximum torque? We know the relation of maximum torque. We derived the relation in previous classes. So this is the relation of maximum torque, 3 V phase square over 2 omega s multiplied by R1 plus square root of 2 R1 square plus X equivalent square. So 3 V phase square is the same as V line square, shabab. Is this right? Because it's star connection here. So we can say 460 square over 2 omega s. So 2 multiplied by 4 by F over number of poles. So this is omega s. After that, R1 plus square root of 2 R1 square. So here there's a missed square, شباب. R1 square plus x1 plus x2, which is the value of x equivalent, all to power 2. So this is here the value of maximum torque. As you can see here, maximum torque is 233 Newton meters. Okay, شباب. We will compare this value later with the other values of starting or full load if it is required here. Regarding speed, in order to get the speed at this point, at maximum torque, we need to get slip. So slip at maximum torque is also well known. It's a function of the parameters. So we can say R2 prime square over R1 square plus X equivalent square. We have all of parameters, so easily we can get the value of S maximum. As you can see, شباب, S maximum is high, صح? يعني we have the operating values of S for the full load, it's 0.02, 0.04 like that, صح? So 0.178, this value is considered very high, تمام? Compared to the full load, يعني. So, يعني if we draw the curve, the torque speed characteristic, so it will be like that, something like that. So this is NS, or here S equals 0. So here S equals 0.1878. This is S maximum. Come on, this is T, and this is here S. Type. So we would like to get the speed now. طبعا speed depends on the value of a slip. So we can say now S1 minus S multiplied by NS will be the value of the rotor speed. So simply we can say here NR equals 1 minus S, 1 minus 0.178 multiplied by NS, which is 1800. We know that it's 1800 because we have 4 poles and 60 hertz 4 poles and 60 hertz motor, or compared to the full load speed. The full load speed is given. Full load speed is not given here, and you don't have the full load speed. However, and it may be recognized also from the given speed of the motor type. So here we can say that this value is the value of S maximum here at this, sorry, n at S maximum equals 1479, which is the speed at this point. Type. Second, it's required to calculate the starting torque of this motor. طبعا starting torque can be calculated from also the equation of torque at S equal 1. So here, if we substitute the torque equation at S equal 1, so the relation will be 3V phase square R2 prime over R1 plus R2 prime square plus X equivalent square multiplied by omega S. So, substitute directly here in this relation, you can find the starting torque here, it's 109. طبعا comparing يا شباب 109 with 233, it's less than 1/2. تمام. So this is the case here. Torque starting maybe according to the curve, it should be according to the values, sorry, it should be like that. Okay, something like that. So this should be the true curve. تمام. One here. And this should be the right curve. Fine. Then it's required to calculate or when the rotor resistance is doubled. طبعا يا شباب, rotor resistance is doubled means we added external resistance because this motor is wound rotor. However, we cannot double the resistance or change the resistance of the induction motor if it is a squirrel cage. So here, because this is a slip ring induction motor, we added a resistance equals to the rotor resistance. So the value of total rotor resistance now will be 2 multiplied by 0.332. So it's 0.664 ohms. And this value now, what will be the speed? We need speed at this case, which the maximum torque now occurs. So we need speed at maximum torque, شباب. And what is the new starting torque of the motor? And also for the new characteristic, what will be the starting torque? If we return again to the characteristic here, and let's draw another characteristic because now this one is not clear. So if this is the first characteristic, شباب, we expect to have the second characteristic by adding resistance. We know that torque maximum will be constant in our adding resistance because maximum torque, as you can see here, this is the relation of maximum torque. There is no R2 prime in the equation, so it's independent of the rotor resistance. So we can say now the curve will be like that. Maximum torque will be constant, and the starting torque according to the characteristic should be increased. So this should be the starting torque in the second case. This is first case. Here, this was the first S maximum 1. So we expect to have also S maximum 2 higher than S maximum 1. So طبعا we have to substitute again in the relations. So we have here the value of R2 prime equals to 0.664. We can substitute now in S maximum relation and give the value of S maximum. This is S maximum value. So we can say speed equals 1 minus S multiplied by NS. طبعا NS is the same. We did not change NS or frequency. So the synchronous speed is fixed here. So we can say 1 minus 0.356 multiplied by 1800. So the speed at maximum torque in the second case will be 1159 RPM. طبعا it's lower than the previous speed. This is logic. Then for the starting torque, we expect to have also higher starting torque. So torque starting, substituting in the same equation at S equal 1, torque starting equal 3V phase square over R2 prime over R1 plus R2 prime square plus X equivalent square multiplied by omega S. substitute here again with the new value of R2 prime, as you can see, and so we get the second value of torque starting. طبعا comparing the torque starting, as you can see, this is here 178, previous one was 109, so the torque starting increased a bit. This is a logic for adding resistance. So up till now, everything is logic. Is there any question, Shabab? Everything is clear now? Fine.
Yes.
Good. Number D, the rotor starting current. The rotor starting current before and after doubling the rotor resistance. طبعا the rotor starting current it means يعني rotor which is the I2 تمام. However يعني we mean all of time it's referred to primary as well. So we need I2 prime تمام يا شباب. Before and after doubling the rotor resistance. يعني we need to calculate the rotor current at both of cases. طبعا starting current can be calculated using the equation of the equivalent circuit يعني V over the A impedance. So this is the relation of current V over square root of 2 real part of the impedance plus imaginary part all squares طبعا. This is going to give you the value of starting current. Take care that we added here R2 prime over S, where we make S equals 1 here because it's starting. So if we substitute in the equation here, you will get the value of current 143.7 ampere in the first case, where R2 prime was without any adding resistance, and in the second case, if the resistance increased, so by adding the same value of rotor resistance, we will have lower current, as you can see here. تمام يا شباب. So يعني everything here now is logic. By adding rotor resistance, the starting current should be decreased. Let me add another part here to the question, شباب. يعني if I turn it back again here to this part and say number E, find the value of R added to make or to start the motor at maximum torque. ها شباب. What will be the value of added resistance to start the motor at maximum torque? ها شباب. يعني in this characteristic, if we would like to add a resistance to start the torque at maximum torque, it means we have to make the characteristic like that. Here, torque starting equals T maximum. What is the condition from here, شباب? What is the value of S maximum in this case now? Let's say S maximum 3. What is the value of S maximum here, شباب?
1.
بالظبط تمام. So S maximum here equals unity. This is the condition now to start the motor at maximum torque. So we can say now, for number E, the condition is S maximum equals unity. So we can say R2 prime square over R1 square plus X equivalent square all under square root of 2 equals 1. طبعا you can square both of sides, so we can say R2 square. طبعا R2 square يا شباب, which R2 square in this case, which R2 at case number 3. Okay, equals R1 square plus X equivalent square. So R2 square in case number 3 equals, we can substitute now by the values we have, which is 0.641 square plus 1.106 plus 0.464 all square, and getting this value and let me calculate it to see exactly the numerical value of resistance. So 0.641 square plus 1.106 plus 0.464 all square. So square root of this value will give you 1.695. So we can say now R2 prime in case 3 equals 1.6958 ohms, which is يا شباب equals to what? Equals to what, شباب? What is the corresponding value of this resistance? It's rotor resistance and the added resistance. Is it right? So this value equals the rotor resistance بالظبط كده. So this is the rotor resistance plus R added. Rotor resistance, we have it here. It's equals to 0.332. So we can get the value of R added. So R added here equals this value minus 0.332, which is 1.364 approximately. 1.364 ohms. طبعا this value has to be higher than the added resistance in the previous case. يعني in previous case we said that the rotor resistance is doubled, which means the added resistance was 0.332. Here we have 1.364 in order to make S maximum equals a unity. تمام يا شباب? So this is a logic now. Any question يا شباب regarding this part? Everything is clear? طيب.
Yes, doctor.
جميل.
But doctor,
اتفضل.
why did we say that S should be 1?
From the characteristic. Let's return to the characteristic again. You know S maximum is the value of slip when the torque is maximum. صح؟
Yes.
طيب, we need here to have T maximum at the point of starting. So S maximum should be at that point. طيب, in the curve here, what is the speed in this point?
The speed?
Yes.
Should be 0.
Exactly. And what is the slip at 0 speed?
1.
Exactly. For that, we said the condition is S maximum equals unity. تمام? So this is the condition to have maximum torque at starting. تمام يا شباب؟
تمام.
جميل. طيب. Speed
دكتور.
control. اتفضل.
طب لو مثلا نبغى مينيموم بدل ماكسيموم.
مفيش حاجة اسمها minimum resistance. minimum ايه تقصد؟ minimum torque؟
ايوه مينيموم تورك.
يعني ايه minimum torque؟ يعني تقلل التورك عن يعني المينيمم انك تسيب الماشين تشتغل زي ما هي. يعني don't make any control. لا مش no load. في فرق ما بين اللودنج والماشين كاركترستيك. اللود ده حاجة تانية خالص. لكن انا بتكلم على الماشين كاركترستيك نفسها. انت عندك كيرف الماشين كاركترستيك اهو، الكيرف اللي قصادنا الحين ده. تمام؟ ايه القيمه بتاعت التورك ستارتنج عند الكيرف ده؟ هي القيمه اللي ظاهره قصادك دي. صح؟
تمام صح.
المفروض ان احنا في الستارتنج بنحاول ان احنا نقلل الكرنت ونزود التورك. نقلل الكرنت ونزود الايه الستارتنج تورك بتاعنا، خاصه لو احنا عندنا ايه كونستانت لود تورك في البدايه. ماشي؟ طيب لو انت مش هتعمل حاجه خالص في الماشين التورك هيفضل زي ما هو. لكن لو هتضيف ريزيستنس يبقى انت بتتكلم ان التورك هيزيد. فانت اقصى حاجه تقدر تزودها انك توصل لماكسيمم تورك. Is it clear؟ لكن ما فيش حاجه اسمها المينيمم تورك بقى هنا. ما فيش حاجه اسمها مينيمم تورك. المينيمم او ما تضيفش حاجه خالص ان انت تسيب الماشين زي ما هي. To work at the same direct online supply. تمام؟
تمام.
regarding الشباب the speed control. طبعا يا شباب يعني in our life no machine is working without speed control. يعني in any application we need to make speed control even in the small applications at home. يعني mixers like blenders, like any application or any motors, you have to make speed control for your motor. طيب, how we can make speed control for induction machine? Let's see the relation from the equation here, torque speed characteristic, the relation between torque and other parameters in the equation, and try to observe together what are the parameters that we can use in order to make speed control. Let's join me please شباب. And here we have 3v square r2 over r1 plus r2 over s to power 2 plus x equivalent square multiplied by s to omega s. So we have the numerator يا شباب. What are the factors that we can use to control now?
Omega and reactance.
Numerator first. Start with the numerator. So we have V
voltage.
exactly.
Voltage.
So we can make voltage control. This is one suitable or one possible control technique in order to control torque along with the S. Also R2 prime, we just discussed the adding resistance characteristic, صح? So we can use also adding resistance to rotor circuit. However, this can be only added to يا شباب, to which type of motors? Which type of induction machine we can add resistance to rotor circuit شباب?
Wound rotor.
Wound rotor or slip ring, this is right. So we cannot do that in squirrel cage machine type. This is for the numerator control parameters. In the denominator, we may have R1, however, it's not used in industry because the benefits of R1 is not or the effectiveness of R1 control on the characteristic is not so good compared to other parameters. So R2, we said R2, we have X equivalent. X depends on the frequency, صح يا شباب? Frequency and inductance. So we may say here we can control frequency in order to control the value of X. تمام? Also, we have omega S. Omega S equals يا شباب 4 by F over number of poles. So by changing, we can change also omega S, and also by changing number of poles. Actually, there is a physical connection for the motor. We can change this physical connection based on some terminals, common terminals connected outside of the motor. We can change the number of poles and controlling the speed by this way. However, this is very old technique. No one uses it now in advanced control techniques or advanced speed control methods. تمام؟ This is very old technique. It's used only for very old machines. But for new drives or new electrical motors, all new electrical motors are based on other controllers, not number of volts. طيب. So for now, شباب, we could now say we can control volt, we can add resistance, we can control frequency and number of volts. So we have 4 parameters. These 4 parameters can be used as follows. So terminal voltage control, pole changing, adding resistance, we said that. We have another technique called slip energy recovery. This is one advanced technique used to improve the efficiency of the machine while controlling the speed of the motor from the rotor circuit side. Instead of adding resistance to rotor circuit, and this resistance definitely will have some losses because there will be I square R on it. So instead of have some losses in the added resistance, we will take this power and return this power to the supply through power electronic converter. In this way, شباب, by controlling the switching of the power electronic converter, we can control the speed, and at the same time, we will return the power to the supply again. So here, we could increase the efficiency by this technique. It's called slip energy recovery. Sometimes in some books, you can find it with the name of static Cramer method. تمام. Also supply frequency as we discussed in the parameters here, and an advanced technique يعني mixed between voltage control and the frequency control in order to keep the machine working at constant flux. Because يعني when we discuss inshallah the voltage control and the frequency control, يعني each technique has يعني its own advantage and drawbacks. The constant flux operation يعني mixes between the advantages of voltage and frequency control. By means of constant flux control, we call it as variable voltage, variable frequency control. Or sometimes you can find it in some other books with the name V over F control, because we keep the ratio V over F constant, which is the ratio of flux, because V over F is proportional to the machine flux. تمام يا شباب؟ So these are the different speed control types. Inshallah, in the next class, we will discuss in details the different control techniques. We will discuss the characteristic for each case. For now, يا شباب, I prepared some before يعني moving to another point. Is there any question regarding speed control, يا شباب? I prepared some MCQs. Can you see the screen now?
Yes.
Word 5? Okay.
Yeah.
I prepared some questions for you يعني to solve it together here. يعني I could find that it's a good way to make an open discussion and see the weak points. So let's start solving it together يا شباب. يعني some of these points يعني some questions here I added, you may يعني listen it to first time, or some you already familiar with it during the classes we already discussed it. So يعني let's يعني cover this part together. First question شباب, يعني the frame of induction motor is usually made of what? The material of the frame itself. Made of silicon steel, cast iron, aluminum, bronze. Do you have an idea شباب? Actually it's frame and stator core as well. يعني both of them are made with silicon.
Cast iron.
لا, silicon steel. So the stator and the frame is made of silicon steel.
دكتور
Okay.
this
تفضل.
is the isolation
لا, this is the core, stator core.
or static core?
The material of core itself, the magnetic material. Okay.
Okay.
طيب. In induction motor, second question شباب, in induction motor, no load or at no load, the slip is generally less than 1%, 5%, 2%, 4%.
Less than 1%.
Less than 1%, I think.
1%.
Less than 1%. You are right. So, يعني the right answer is less than 1%. طبعا يا شباب يعني at full load speed, the slip is around 2%, 4%, like that. So no load speed, it means you have higher speed. So we expect to have يعني much lower slip. طيب. Three-phase 440 volt 50 hertz induction motor has 4% slip. The frequency of rotor current will be 50 hertz, 25 hertz, 5 hertz, 2 hertz. ها يا شباب. What is the frequency of rotor current?
2 hertz.
2 hertz, exactly. Why? What is the relation? Huh?
Frequency multiplied by the slip.
Exactly. So the relation here is F2 equals SF1. You are right. تمام. طبعا يا شباب, we discussed this before and we said at the operation of the motor, the frequency of the rotor circuit will be the frequency of cutting speed, تمام, which became very small at the steady state. يعني it starts with the same frequency and the frequency will be reduced at steady state to very small value. For that, the rotor current frequency will be very small or very close to DC, because we said 2 hertz or 3 hertz, like these values are considered very small value, or close to DC current, because it stay very long time in positive half cycle, and similarly very long time in negative half cycle. طبعا long time we refer here or relative to the electrical time constant. تمام. A double squirrel cage or double cage induction motor equivalent to 2 series windings in stator, 2 parallel windings in stator, 2 parallel windings in rotor, 2 rotors moving in opposite directions. ها شباب. What do you think? Squirrel cage or double cage? We discussed it in the previous class. One of the techniques to reduce the starting current is to make different shape for cage.
parallel دكتور.
Yeah, it's a parallel, right? But let me give you a figure to see the difference, or to see the double cage. As you can see, this is the squirrel cage machine rotor. صح كده شباب? This is the A cage. However, instead of have 1 bar like that, we will have 2 bars. One small at the outer side, close to the air gap, and the other is or with a high cross-section area, and it will be close to the center or shaft of the rotor. تمام? And we said that the idea is at starting the frequency will be high, so the flux will move here in this area. Okay. However, at steady state the flux will be with a small frequency, so it will move in this area. So by this case, شباب, we will have higher resistance due to small cross section, and this is the needed one for the starting the induction motor safely at small current. تمام? And after that, the small resistance will be attained by the other cage here, which is the lower one. Okay, so and this will help in starting the machine at lower current. So the right answer here, as you already mentioned, 2 parallel winding in rotor. So this is the right answer. طيب, another question is 50 Hz 3-phase induction motor has full load speed of 1440 RPM. The number of poles of this motor is, what do you expect?
6.
Why 6?
I remember it was 6.
Can
6
you
or 8.
calculate? Can you calculate?
2 دكتور.
طب احنا بنجاوب على اساس يا شباب؟ ممكن can you justify your answer؟ why it's 2 or why it's 6؟
لأنه دكتور إنه إذا كان 4 بولز فحيكون 1800.
ده الكلام ده لو 60 هرتز.
Oh, 50 Hz. Okay.
But here it's 50 hertz.
4 poles.
It's 4 poles. This is right. Because at 4 poles with 50 hertz, the synchronous speed is 1500. So 1440, it's close to the 15. So this is the logic one. Even if the frequency is not given, لو الفريكونسي مش موجود هنا, what will be the value of speed which is very close to 1440? What will be the synchronous speed which is very close to this number? Is it the speed is limited? You have either 1200, okay, which is obtained at 6 poles 60 hertz, تمام, or 900, which is very far also for this one, which is 50 hertz 6 poles. So 6 poles is not sufficient now. So in 4 poles we have 1500 and 1800. So 1500 is close to 1440. So this is the right answer. يعني even if the frequency is not given, you have to compare and يعني recognize the suitable value. طيب. A three-phase 50 Hz induction motor has a full load speed of 1440. The full load slip will be what will be the full load slip now يا شباب? We agree together now the synchronous speed is 1500 صح? If you calculate the 1500, so 1500 minus 1440 over 1500 will give you the value of 4%. So this is the right answer يا شباب. And just calculate it using your calculator, you will find this is the right answer. طيب. The better power factor of an induction motor can be achieved if the average flux density in the air gap is infinity, large, absent, small. What do you expect, شباب? Let's analyze it together. In order to have high power factor, what should be the impedance? Resistive, highly resistive, or highly inductive?
High
Highly
resistance.
resistive.
Highly
Resistive.
resistive. This is right. So in order to have low inductance, you have to make the flux low as well. صح ولا غلط? So here the right answer is small. This will give you the small value of a inductance part, and at the same time the power factor will be high. طبعا يا شباب يعني I do prefer to modify here the question a bit. The better power factor of induction motor, let's say the better starting power factor, because this is not the case at full load, because at full load you will have something extra due to dynamics, and this is going to increase the resistance. صح? Even the flux is high. Due to operation with high value of flux, even if you are close to saturation or before of saturation by a small value. So at full flux or high value of flux, even the flux is high and the inductance is high, slip will be very small. صح ولا غلط شباب? And if the slip is very small, the equivalent R2 prime over S will be very high. For that, the power factor also will be very high. So, the right expression or the better expression to say here, the better starting power factor, not operating power factor. ماشي? And this is much better compared to previous expression, because this is more valid at start. طيب. The auto starters. Auto starters, this is very general expression يا شباب. For that it's stated here using 3 auto transformers. So from the meaning here, they mean that auto starter, so he will use auto transformer to start induction motor. So the auto starter using 3-phase auto transformer can be used to start cage induction motor of the following type: delta connected only, star connected only, both 1 and 2, and none of the above. شباب. We discussed the auto transformer in the last class. Both, exactly, because we can connect the transformer or the windings as star or delta. So the right answer should be both. طيب, if we modify the question here يا شباب to be with slip ring here, and instead slip ring first part, number 1 slip ring, number 2 squirrel cage, number 3 both, and number 4 none. What will be the right answer? again auto transformer, and we said here instead of delta and star connections, we can say here slip ring induction motor, and number 2 squirrel cage induction motor. So which solution is right? Hi شباب. Can we use auto transformer with slip ring يا شباب؟
I don't think.
What is the function of auto transformer? What is the function of auto transformer to start the machine? يعني what will the auto transformer make in order to start the machine يا شباب? We just discussed it يعني in the last class. When we start with auto transformer, what happens? The voltage يا شباب, the voltage should be decreased. صح ولا غلط? We said in order to decrease starting current, we have 2 different ways, either changing the volt or decreasing the volt or adding resistance to rotor circuit. صح? Adding resistance to rotor circuit, it's limited only to slip ring induction motor because we cannot add resistance to the squirrel cage. يعني no terminals to add resistance to squirrel cage. تمام? However, controlling the voltage, you can control the voltage for either slip ring or squirrel cage because يعني all of cases you have terminals for the stator and you have to supply stator. So you can apply this technique for all of a induction motors type. تمام يا شباب؟ If any 2 phases for an induction motor are interchanged, what will happen يا شباب? The motor will run in the reverse direction. The motor will continue to run in the same direction. The rotor will stop. The rotor will burn.
الأولى دكتور ممكن.
أنا معلش ما سمعتكش بتقول الإجابة إيه؟
Reverse direction.
Reverse direction. This is right. طيب why it's reverse? Huh?
Because you interchange between the 2 phases.
Exactly. Interchanging 2 phases means you reverse the sequence from ABC to ACB. So the flux rotation will be the opposite direction. So the motor will be reversed. The motor direction will be a reversal. This is right. تمام. طيب an induction motor is تاني an induction motor is self-starting with high torque, self-starting with 0 torque, self-starting with low torque, not self-starting. ها شباب؟
Self-starting with high torque.
No, low torque.
with low torque. احنا لسه قايلين من شويه ان التورك في الستارتنج بيبقى قليل واحنا عايزين نزوده، علشان كده كنا بنضيف ريزيستنس. صح؟ يعني الستارتنج وذ هاي تورك هتلاقيه موجود في الايه؟ في الدي سي سيريز موتور. تمام؟ برضه في يا شباب موديفيكيشن بالنسبه للاندكشن موتور. بعض التصميمات او بعض الكلاسز للاندكشن موتور، في عندنا 4 كلاسز، كلاس A B C and D. يعني each one has its own design, and based on this design we can make starting torque higher or lower. So يعني for the natural characteristic what we already discussed in our classes, which is class A by the way. For class A the torque starting is low, it's not high. يعني we could see that torque starting is around the full load torque, يعني maybe يعني 1 times the full load torque, or maybe higher a bit. However, it's not like maximum torque. صح ولا غلط؟ يعني in DC series motor the maximum torque will be at starting. مظبوط؟ However, the case here is not like the DC series motor, but for one of the classes, which is class D induction machine, class D has starting torque equals to maximum torque. It has the same characteristic or very close to the characteristic of adding resistance. تمام؟ when we add resistance and make torque starting equal torque maximum, we have already a designed motor like that. But for this motor, the efficiency is very small. تمام؟ So it's not a preferred. خلاص شباب؟
دكتور
تفضل.
لما انت تحط السؤال هتحط الكلاس حقه وش هو النوع عشان نفرق؟
خلينا بنتكلم ان جنرال. انتوا لحد دلوقتي اللي درستوه في المنهج كله ما يخص كلاس A. ماشي؟ مش عايزين نوسع المواضيع عليكم، فخلينا بس نقتصر على كلاس A دلوقتي. فاحنا عندنا الجنرال ايديا اللي احنا درسناها ان في كلاس A ان الستارتنج تورك بتاعنا مش عالي. So the right answer is self starting with low torque. Okay. This is the best answer of these three answers. طيب somebody can say it's not self start. Is it right? What is the meaning of self start? Exactly. Because somebody confused about we need starting for induction or starting solution for induction motor. So it's not self start. Like we said before, starting solutions for induction motor to avoid high current. However, the motor is self starting motor. طيب. 3-phase squirrel cage induction motor يا شباب او in 3-phase squirrel cage induction motors, rotor conductors are kept open ولا rotor conductor ends are shorted or short circuited through slip rings ولا rotor conductors are short circuited through end rings ولا rotor conductors are connected to the insulation. ها شباب, what do you think? Which is the right answer?
3.
3.
3, exactly. We have end rings for on both of sides of conductors. طبعا there is no slip rings in a squirrel cage motor, and if we left the conductors open, the motor will not start. It will not work. تمام, because there is no winding in this case. It's just bars without any connections. تمام. And last one, rotor conductors are connected to the insulation. طبعا if it's connected to insulation it's how to connect conductors to insulation. You mix it between the insulations and conductors. how the current can move in the insulations. تمام. So it's not logic completely. طيب.
Not logic.
Yes, exactly. So at another question, at standstill يا شباب means the motor speed is 0. Okay. At standstill condition, the value of the slip is 0 ولا infinity ولا 1 ولا none of the above.
1.
1, exactly. تمام. طيب. The condition for maximum starting torque, we just solved this in our problem. The condition of maximum starting torque is R2 prime equals S multiplied by X over 2, ولا R2 prime equal X over 2, ولا X multiplied by S, ولا X. What is the condition? Let's write the equation together. The equation is S maximum. We said the condition that S maximum equal unity, and X maximum, if we neglect the stator resistance, it will be R2 prime over X equivalent. صح? This is the condition for maximum starting torque. So from this relation يا شباب, R2 equals what? S multiplied by X. Is it right? S multiplied by X. This is equal to R2. So the right answer here is the third one, x multiplied by a by s. طيب. In which of the following region induction motor operation is stable? We discussed the stability يا شباب of induction motor and we said which region يا شباب? Low slip region. Low slip
region.
Exactly. This is a completely right. يعني last question, rotor resistance speed control method is not applicable in rotor resistance speed control method is not applicable in squirrel cage induction motor. Exactly. طبعا because squirrel cage we cannot add resistance. طيب يعني this is enough for today شباب. We can continue إن شاء الله يعني solving the remainder questions and discuss the speed control in the next class. Any question يا شباب؟
دكتور
Yes.
في هيكون لسه كويز على الاندكشن
إن شاء الله.
ولا خلاص كده؟
There will be a quiz for induction motor إن شاء الله.
طب دكتور هل بيكون الأسبوع الجاي ولا آخر أسبوع 16؟
بعد ما تسلموا الهوم وورك على طول. الهوم وورك احنا قلنا يتسلم امتى؟
لا.
Let me first بس يعني stop the recording and we can continue discussing.